Till now, we have balanced 4 chemical equations out of the 9 we are supposed to balance, correct? Now, in this session, we will try to balance the remaining equations, okay? So, here goes the 5th equation that we are supposed to balance. That is the reaction of hydrogen with chlorine. So, hydrogen, which is in the molecular state H2, will react with chlorine to form hydrochloric acid, which is given by HCl. Right? Now we got a equation. So first thing that we are supposed to do is we have to check whether the reaction is balanced or not. So to check this, we have to verify the atoms. So first let's verify the atoms. What are the elements present in this given equation first? Hydrogen is one element present, chlorine is present, and similar, okay, only 2 elements are present now. So what is the number of atoms on the reactant side? Hydrogen, there is 2 atoms, whereas on the product side there is only 1 atom. Whereas on the reactant side the chlorines are 2, whereas on the product side it is only 1. So this is not balanced, so this is also not balanced. So the equation is a skeletal equation which is unbalanced. Now how to balance it? So in balancing, the first step is never touch anything that is inside the formulae. We are not supposed to make any changes to this formulae, correct? Then what is the next step? We should know what atoms to balance first. So in figuring out what is the first step, we figure out what is the compounds present in this given compound. So the only compound present in this is HCl. So now in HCl, we will try to see which atoms are present in maximum quantity. If you look at this, there is only 1 hydrogen and 1 chlorine. That means you can start balancing with any of the atom. So first let me take chlorine. So now in balancing chlorine, how many chlorines are there on the reactant side? 2. Whereas how many are there on the product side? Only 1. Correct? So that means I have to balance chlorine. So I have to ensure that I make on the product side also 2. Now to make 2 chlorines, how do I make this 2 chlorines on the product side? Here there is 1. I am not allowed to alter anything in this chemical formulae, but I am allowed to alter the stoichiometric coefficient. So now how do I alter the stoichiometric coefficient? I make the stoichiometric coefficient as 2 into 1. Correct? Now it becomes balanced. So my new equation will be H2 plus Cl2 forming 2HCl. So now check, there is 2 chlorines, 2 chlorines. So chlorines are balanced. Then how about hydrogens? So if I am looking at hydrogens, on the reactant side there are 2 hydrogens. On the product side there are 2 hydrogens. Correct? Here also 2 hydrogens. So because this is my new equation, correct? Hence hydrogens are also balanced. Hence the equation is a balanced chemical equation. You understand this? Okay, let's go with one more example. Here we will take as a 6th example, we will take reaction of barium chloride with aluminium sulphate. What is the formula of aluminium sulphate? Al2SO4 taken thrice. So the reaction here is a precipitation reaction. So that means you get a white colored precipitate which is known as barium sulphate plus AlCl3, which is aluminium chloride. Understand? Now let's check whether the given reaction is balanced or not. So to check this, we have to go with all the atoms present in this particular equation. So we have barium atoms, chlorine atoms, aluminium atom, sulfur atoms, and oxygen atoms. So we have 5 different types of atoms. Now how many are there on the reactant side is the question, and the product side. If you look at the reactant side, there is only 1 barium. So 1 stoichiometric coefficient into 1. So 1 barium. How about the product side? Here also 1 into 1. 1 barium. Chlorines are 1 into 2. So 2 chlorines. Whereas on the product side 1 into 3. 3 chlorines. So this is balanced, but this is not balanced. Okay. Let's look at aluminium. Here there are 1 into 2 aluminiums on the reactant side. On the product side, there is only 1 aluminium. So this is also not balanced. Then how about sulfur? Here there are 1 into 3. That is total 3 sulfurs. But whereas here you have only 1 sulfur. So sulfur is also not balanced. Then how about oxygen? So if you look at oxygen, there are 4 oxygens inside the bracket. So 4 into 3. That is 12, and 12 into 1 stoichiometric coefficient. So total there are 12 oxygens, but here there are only 4 oxygens. Correct? So this is also not balanced. So this equation is a skeletal equation. That means you have to balance this equation. Now in balancing, what is the first step here? You should never disturb anything that is inside the chemical formulae. That means you are only supposed to alter the stoichiometric coefficients. Now next thing, what to balance is the question. So now what to balance, you have to figure it out by checking what are the compounds. You have all 4 compounds: barium chloride, aluminium sulphate, barium sulphate and aluminium chloride. So all of these are compounds. So now in all the compounds, which compound has maximum number of atoms is the question. So let's check here. There are 3 atoms. Here there are 4 plus 1, 5 atoms in the bracket. 5 3s are 15 atoms. 15 plus 2, total 17 atoms here. Whereas here 4 plus 1 plus 1, that is 6 atoms. Here 3 plus 1, 4 atoms. So if you look, aluminium sulphate has 17 atoms. So we have to balance aluminium sulphate atoms first. In that, which atom should be balanced is the question. So we have to balance which is maximum in number. So which is maximum in number? Oxygen. So we start the balancing with oxygen. So now oxygen to balance, let's check how many oxygens are there on the reactant side. So on the reactant side, we have 4 3s are 12, 12 into 1. So total 12 oxygens. Then on the product side, we have 1 into 4, only 4 oxygens. Now we have to balance it. That means on the reactant side, there are 12. So on the product side also, we should get 12 oxygens. Now how do I make this 12 oxygens? Already there are 4. So if I make the stoichiometric coefficient 3, then it is 3 into 4 becomes 12. So that means I have to make the stoichiometric coefficient into 4. This is my stoichiometric coefficient. So my new equation becomes what? BaCl2 plus Al2SO4 taken thrice will give me what? BaSO4 plus AlCl3, and here 3 should be added in front of barium. So here it is 3BaSO4. Now 4 3s are 12 oxygens, 3 4s are 12 oxygens. So my oxygens are balanced. Now what is the other atom which is maximum in number? That is sulfur. So let's try to balance sulfur now. So in balancing the sulfur, let's see how many are there on the reactant side and on the product side. So if you look at the reactant side, there are 1 sulfur into 3, total 3 sulfurs. That is 3 into 1 stoichiometric coefficient. There are only total 3 sulfurs. So on the reactant side, there are 3 sulfurs, and on the product side, you have here BaS1O4. So 1 into 3, 3 sulfurs. So my sulfurs are already balanced. So I need not balance sulfurs anymore. Correct? Then what is the next thing I have to balance? Aluminium I have to balance. So let's write here aluminium. So in balancing aluminium, we have to check on the reactant and the product side. So on the reactant side, you have 1 into 2. So total 2 aluminiums. Whereas on the product side, only 1 aluminium. So it is not balanced. So we have to balance it. We have to make it equal. So if you want to make it equal, that means 2 and 2. How do I make on the product side 2? Here I have to manipulate the stoichiometric coefficient. So already there is one aluminium. So if I put 2 here, 2 into 1 becomes total 2 aluminiums. So I should make 2 into 1. So my new equation will be what? Barium chloride plus Al2SO4 taken thrice will give me 3BaSO4 plus 2AlCl3. So now my aluminium are also balanced. And then what else we have to balance? Let's balance barium. So in balancing the barium, we have to check on the product side how many, reactant side how many, and on the product side how many. If you look at the reactant side, there is only one barium, but whereas on the product side there are 3. So you have to balance this barium. So that means I have to make it 3 here, and here also 3 I have to make it. But on the reactant side, how do I make it 3? Here is only one barium. So I have to ensure that I change the stoichiometric coefficient to 3. So that means my new value will be what? 3 into 1. So my new equation will become 3BaCl2 plus Al2SO4 taken thrice will become 3BaSO4 plus 2AlCl3. Understood? Now let's look at one final atom, that is chlorine. So in balancing chlorine, on the reactant side we have 2 into 3, that is 6 chlorines. And whereas on the product side you have 2 into 3, 6 chlorines. So my chlorines are also balanced. Now, do you think this equation is a complete balanced equation? So now to confirm this, let's verify it once again. So 3 bariums, 3 bariums. Whereas 3 2s are 6 chlorines, 2 3s are 6 chlorines. 2 aluminiums, so 2 into 1, 2 aluminiums. Then sulfur, 3 into any stoichiometric coefficient is 1. 1 3s are 3 sulfur. So 3 into 1, 3 sulfur. So sulfurs are also balanced. And the final one is oxygen. 4 into 3, 12. 12 into stoichiometric coefficient 1 is 12. So 12 oxygens are there. Here also 4 into 3, 12 oxygens are there. So this is a complete balanced equation. So this is a balanced chemical equation. You understand this? Did you understand the procedure how we balance this equation? Let's do one more question. Okay, we finished with 6th. Let's do the 7th one. So in the 7th one, instead of taking aluminium sulphate, I will take a different substance, that is reaction of barium chloride with sodium sulphate, that is given by Na2SO4. So when this reaction occurs, you get the similar type of product, that is barium sulphate plus sodium chloride. This is the product form. Now you have to check whether the given reaction is balanced or not. Now to check, what is the first step you have to do? You have to know what are the atoms. So here you have what atom? Barium atom is there, chlorine atom is there, sodium, sulfur and oxygen. And on the reactant side, you have how many bariums? 1 into 1, it is only 1 barium. Whereas on the product side, it is 1 into 1, 1 barium. So barium is balanced. Then how about chlorine? Here it is 2 into 1, 2 chlorines. Here also you have chlorine here, 1 into 1, only 1 chlorine, but it is not balanced because they are unequal on the product and the reactant side. Then sodiums, 1 on stoichiometric coefficient into 2, that is 2 sodiums. Here there is only 1 sodium. So sodiums are also not balanced. Then how about sulfur? 1 into 1, 1 sulfur. Here also 1 into 1, 1 sulfur. Sulfur is balanced. Then finally oxygen. 4 into 1 stoichiometric coefficient, that is 4. Here also 4 into 1 stoichiometric coefficient, 4. So both are balanced. Do you understand? So oxygens are also balanced. But still you have some unbalanced atoms. That means the equation is a skeletal equation, but it is not balanced. Now, how to balance it? You should not change any term inside the formulae. Then what is the next step? You should know what to balance first. So in getting to know, you should know what are the number of atoms present in the given compounds. Here there are 3 atoms, whereas here 2 plus 1 plus 4, that is total 7 atoms. Here 4 plus 1 plus 1, 6 atoms. Here 2 atoms. Now which one will you balance first? Sodium chloride, correct? So in sodium chloride, which atom will you balance first? Again, oxygen you will balance because it is 4 in number. So now to balance oxygen, the number of oxygens on the reactant side are 4 and the product side also 4, but it is already balanced, correct? So then what is the next atom we should balance? That is sodium, because after here there are 2 sodiums in this. So let's go for sodium. So if you take sodium, on the reactant side you have 2 sodiums, whereas on the product side you have only 1 sodium, but you have to make them equal. That means if there are here 2, here also you should have 2. Now how do you make on the product side 2 sodiums? That means you have to manipulate the stoichiometric coefficient to 2. So that means I have to multiply 2 as the stoichiometric coefficient into number of sodium, that is already 1. So my new equation will become what? Barium chloride plus Na2SO4 giving rise to barium sulphate plus 2NaCl. Correct? So it will become 2. Now my sodiums are also balanced. Now I have to balance sulfur. Now to balance sulfur, I have to take sulfur on the reactant side is only 1, whereas on the product side is also 1. Correct? Here it is 1 into 1, 1, 1 into 1, 1. So sulfur is also balanced. Then I will try to balance barium. So if I look at barium, on the reactant side, I have 1 barium, that is 1 into 1 is 1, whereas on the product side also I have 1 barium. So my barium is also balanced. Then finally I have to balance chlorine. So in balancing chlorine, on the reactant side I have 2 chlorines, whereas on the product side I have 2 into 1, hence 2 chlorines. So my chlorine is also balanced. All the atoms are balanced. But what is the final step? You have to check if all the atoms are balanced or not. One final verification. 1 barium, 1 barium. 2 chlorines, 2 into 1, 2 chlorines. 1 into 2, 2 sodiums, 2 sodiums. Whereas here 1 sulfur, here also 1 sulfur. Whereas here 1 into 4, 4 oxygens. Here also 1 into 4, 4 oxygens. You understand? So this equation is a balanced chemical equation. You understand this? Now we will try to solve one more, that is your 8th equation, a simple neutralization reaction. So here an acid will react, that is HCl, reaction with sodium hydroxide, which is given by NaOH. And here the product formed is NaCl plus H2O, that is water. Now we have to balance this reaction. So to balance this reaction, first let's see if the reaction is balanced or not by looking at the atoms present in the given equation. So if you look at what are the atoms here, hydrogen is present, chlorine is present, sodium is present, and oxygen is present. Then how about the reactant side hydrogens and the product side hydrogens? Here hydrogen is only 1 into 1, 1 hydrogen. Here also, here it is 1 plus 1, total 2 hydrogens are there on the reactant side, whereas on the product side here 2, 1 into 2, 2 hydrogens. So hydrogens are balanced. Now we have to balance chlorine. If you look at chlorine here, then it's 1 into 1 is 1 chlorine, whereas here 1 into 1, 1 chlorine. So chlorine is also balanced. Then sodium, here we have 1 sodium, here also 1 sodium on the product side. Sodium is also balanced. Now let's balance the final oxygens. So 1 into stoichiometric coefficient 1, here also it is 1, here also 1 into 1, 1 oxygen. So oxygens are also balanced. So you look at this equation, all the atoms on the product side and on the reactant side are balanced. So here the skeletal equation has become a complete balanced equation. So this is balanced chemical equation. Understand? And till now we have balanced how many here? 1, 2, 3, 4. And in the last class we only balanced 3. And if you look at the numbering, I made a mistake here. This is actually the 4th one, 5th one, and 6th one, 7th one. That means we are left to balance 2 more equations, and these 2 are really important. And I will share you one of the method. In this equations look very simple, but there is difficulty in actually balancing these equations. I will share you one of the method that was actually shared by my teachers in balancing this kind of equations. Okay, and I'll see you in the next session. Thank you so much.